Okay, welcome to Spring Semester Standards for Math 1. Today we're going to be going over Standard 1, solving a multi-step equation. All that means is this is an equation that requires more than one operation to isolate the variable we're solving for. Let's look at problem 1 together. This problem says the square root of the quantity v plus 2 is equal to 3. So there are a few ways we can solve this. Let's start by looking inside, and then we'll also look at how to solve this problem using undoing. So for looking inside, I see that the square root of some number is 3. So what number has a square root of 3? Another way to think about this is 3 times itself equals what? Because that's what makes 3 the square root of this number. So the number that has a square root of 3 is 9, which means inside this root symbol must be a 9. Knowing that, when I look at that root symbol and I see v plus 2, I can say v plus 2 has to equal 9. Then, to isolate v, since 2 is being added to it, I want to do the opposite and subtract 2 from both sides. If I do an operation to one side of my equation, I have to do that same operation to the other side. So I end up with v equals 7. So that's looking inside. Alternatively, the way to undo a square root is to square both sides of the equation, aka raise both sides to the second power. When I do that, I once again end up with 9 on this side, and then the square undoes the square root. So these operations cancel each other out, and on this side, I end up with v plus 2. Now we're back at this spot, and I can perform the same operation to isolate v. I subtract 2 from each side and get v equals 7. For this second type of equation to solve, I like to isolate my term that has the x in it first so that I can use the cross products property, aka cross multiply and divide, to isolate my x. Right now, the term that's keeping my x term from being by itself is this 5/8, and it's being subtracted. So to undo that, I'm going to add 5/8 to both sides of my equation. When I do that, I end up with x divided by 6 is equal to 4 and 5/8. It's not very helpful to have a mixed number here, so let's change this 4 into eighths so that I can add it to the 5/8. To do that, I'm going to rewrite this 4 as 4 over 1, and then I'm going to put a little plus sign between the 4 over 1 and 5/8. Next, since the denominator for the 5/8 is 8, I want to multiply the numerator and denominator of the 4 over 1 so that my new denominator is an 8. What do I need to multiply 1 by to make it 8? 8. When I do that, I get 32 over 8. Now I can add my fractions together because they have a common denominator. 32 plus 5 is 37. So the right side of my equation is now 37 over 8. Now I'm ready to use my cross products property. To do that, I multiply my numerator on the left and my denominator on the right, and put those on the left side of my equal sign. Then I multiply the denominator on the left and the numerator from the right and put that product on the right side of my equal sign. 37 times 6 is 222. So my new equation says 8x equals 222. Lastly, to isolate my x, I need to divide both sides by 8. When I do that, I get x equals 222 over 8. Because those are both even numbers, 222 and 8, I can divide my numerator and denominator by 2 to simplify and end up with 111 over 4. If you are asked for a decimal response, you would get 27.75. For our final problem type, we're going to mostly use the ideas of rewriting and undoing. So given this equation, 1 plus 3 times the quantity, n plus 8, is equal to 19 plus 5n. We want to solve for n. First, I am going to address any parentheses on both sides. So I see parentheses over here. That tells me the whole quantity, n plus 8, is being multiplied by this 3. I distribute the 3 to both terms inside the parentheses, and personally, I like to just draw these little arcs so that I remember to distribute that 3. My new equation says 1 plus 3n plus 24 is equal to 19 plus 5n. Now I'm going to combine like terms on each side of my equal sign. So on the left side of my equal sign, this 1 and this 24 are like terms because they're just numbers, they're just constants. When I combine those, I get 25. The 3n doesn't have any other n's to play with on the left side of this equal sign, so it just stays a 3n. So my left side becomes 25 plus 3n. On the right side of my equal sign, 19 and 5n are the only terms, and they are not like terms, so that just stays 19 plus 5n. Next, I want to get all of my terms that are just numbers and move them to one side of the equal sign, and all of my n's on the other side of the equal sign. To do that, I'm going to first subtract 3n from both sides. So now I have 25 equals 19 plus 2n. Next, I will subtract 19 from both sides of my equation and get 6 equals 2n. Last but not least, I need to divide both sides of my equation by 2 so that I get 1n by itself. And we see that 3 is equal to n. I hope that was helpful. Try a few of these other problems on your own, and then you can always come back and re-watch this process if you get stuck.